Alright, this time I would like to share with you about the inheritance of blood group based on the use of genetic diagram. Okay, so genetic diagram is a diagram that if we know the genotype of the parents, okay, then based on the meiotic cell division, we know that it is turning from diploid to haploid, producing the gamete. Okay, the gamete, of course, the male individual will be sperm and the female individual will be ovum. Okay, and when the sperm and the ovum fuse together, it form a zygote, right? And that's why we call if the both of the alleles are the same, then we call it homozygous. And if the alleles are different, then we call it heterozygous. Based on that, based on the zygote concept. Okay, so there's a diploid, there's a haploid. So we can learn from the genotype, and when it has been split and the sperm and the ovum fuse together, we can study the ratio as well. The phenotypic ratio can also be studied, okay, based on this kind of diagram. So let's talk about the blood group, okay? Back to here, blood group. Now, we know there are four possible blood groups, okay, that we're going to study. Blood group A, group B, group AB, and group O, okay? So we have these four common blood groups that we are going to study. And the possible genotype based on that would then be controlled by a pair of values, and of course, it could be LIAIA, so then it would be homozygous dominant 1, okay, it would be homozygous dominant for blood group A, and of course it could also be like a big IA and a small I as well, then it would be a heterozygous, because we know that the small letter is for the recessive allele and the big letter is for the dominant allele, right? So same for B, okay, but group B as well. So if it is both big IB, then it will be homozygous dominant B. And if it is a big IB and small I, then it will be heterozygous, okay? So heterozygous type of B. And because the allele for big I and big I are equally dominant, and we can call it codominant actually, then it would be a blood group AB. And if both of them are small I, then it will be a blood group O. Okay, so from these six possible genotype, okay, we can start deducing, okay, the monohybrid course. Okay, and think about like you can actually ask your parents about, okay, what blood group are they having, and you will know whether you are adopted or not. All right, I'm just kidding. Okay, that's the fun of learning biology. Okay, so let me use an easy example first, okay, shall we? Now, say for example, like if you have blood group A, okay, and blood group O, okay, as both of the parents, okay, male parent having blood group A and the female parent having blood group O, okay, and assume, okay, the parent is actually heterozygous, okay, that it will be making sense, okay, or like homozygous will also do actually. Okay, let's do homozygous first. Okay, then it will be a big IA, a big IA. Okay, that is for the homozygous dominant parent blood group A. Okay, and of course, like blood group O, there is no possibility. It will be only small I and small I. Okay, so they undergo meiotic cell division. So there are two gametes. Okay, over here possible. Okay, one of them is big IA, and the other is also big IA. And of course, I know, okay, some of you will actually just white run one gamete, okay? But for easier representation over here, because we are just like doing grade 7 biology over here, okay, it is okay. So, and for group O over here, it is having a small I and small I, okay? So, if your father is having a homozygous dominant A, and your mother is having O, now the possible gamete over here after doing the monohybrid course and the offspring, look at here, if it is like big IA and small I over here, then one of the possibility is that big IA and small I, right? And the other possibility is that, okay, you're using these two, okay, two sperm cannot fuse together, okay, two ovum cannot, but sperm and ovum can, okay, so that's why big IA small I over here, okay, big IA and small I. Now over here again, big IA and small I, and big I and small I. Now with that in mind, okay, actually the genotype, we show all the genotype over here, and the phenotype, what is the phenotype? The blood group will be A, and A. So if your father is having homozygous dominant A, and all of his offspring should be blood group A. Okay. Okay. If you're having blood group B, okay, you're so unlucky you're adopted. Okay. So another possibility, okay, is that okay the blood group A is actually heterozygous. Now we work on another example. Okay. Again, blood group A and blood group O, and the parent over here. Now the course, okay, you should write out the course. Okay, you should know how to draw a genetic diagram as well. Now it is having a heterozygous type of blood group A, then it will be big IA and small I. And over here, blood group O, then it will be small I. Okay, do it in split over here. Two possible type of gamete for O, then it will be big IA and small I. And for O, it could only be small I and small I. Okay. Now during the course over here, so big IA and small I over here. So is one of the possibility, and big IA and small I again. So big IA and small I. Now here, small I and small I, and small I and small I. So with that in mind, so possible phenotype would be blood group A, blood group A, blood group O, and blood group O. So we can learn if your father is having big I and small I, that's a heterozygous blood group A, and your mother is having blood group O, okay, it should be homozygous recessive in nature. Then you would have 50% of chance, okay, 50% of chance having blood group A, and 50% of chance having blood group O, okay, given that they are going to give another child, okay, give birth to another child, okay, so then there would be 50-50 chance. Understood? Now that's so easy, isn't it? So we can work on more examples, okay, and see whether you can deduce your own your blood group and in your whole family, okay, as well. All right, now some interesting example might be we work on A and B, okay, blood group A and blood group B, okay. Now blood group A and blood group B, let's say both of them are heterozygous, okay, then there will be like a big IA and small I, big IB and small I as well. Now, if that's the case, then the possible gamete, okay, from these two parents, okay, the gamete from the male parent over here is big I and small I, and the female parent over here is big IB and small I. Now, that's so funny. So, blood group A and blood group B can actually give birth to a child of, like, look at these two gametes fused together, okay, it will be co-dominant IA and IB. So, then they can actually give birth to child AB, okay? It's possible, okay? Even they are not AB and they can give birth to AB. Now, look at here, IA and small I, okay? So then it will be giving birth to a child having blood group A. Now over here, okay, we will write the big letter first, okay? So IB and small I, so it will be B, and finally small I and small I. So it will be O. Now, actually, it will be having 25% of chance having blood group AB, 25 for A, 25 for B, and 25 for O. Okay, of equal chance. Okay, if you have parents of A and B and both of them are heterozygous, you can have all sort of blood groups. Now, another interesting one will be crossing AB and O. Now, crossing AB and O, okay, let's do it. Now, there's only let me think. Okay, two possibilities actually. Think about that. Like, okay, I have asked this question in class as well. If your father is having blood group AB and your mother is having blood group O, can you have a child of AB and can you have a child of O? The answer is definitely no. Okay, if you know that, okay, your parents, okay, one of your parents is AB and one of your parents is O, and you are AB or you are O, okay, you're so unlucky again, you're adopted. Okay, let's work on the biology. Okay, so blood group AB implies that the parent is actually having codominant IA and IB, big IA, big IB. And for O, it will be small I and small I. Now, so easy. Now, then the gamete, okay, the parents, okay, the male parent over here, big IA and big IB for the gamete. And for the O, then it will be small I and small I. Small I and small I, understood? So Based on that, okay, the offspring, it is possible for it to be I over here. So big IA small I. Okay, big IA small I again over here. Okay, and big IB small I and big IB small I. Look, it could only be but group A, but group A, but group B, and but group B. Okay, and all of them are heterozygous actually. So it will be 50% of chance having A and 50% of chance having B, but 0%. Okay, for blood group AB and O, 0% of the offspring would be AB and 0%. It's impossible to have O again. Okay, now that's so funny, isn't it? Ha! All right, and actually you can continue work on many other possibilities, or like mixing A, B, and A, or like B and O. Okay, we do. Okay, or might be we should work on one more example. What do you like? Or might be A, B, and A. Okay, so my final example with you now. A, B, and A. Okay, now given that the AB is only codominant IA and IB. Okay, big IA, big IB, and the blood group A over here, let's say it is heterozygous. Okay, so then it will be big IA and small I. Now with that in mind, the gamete, okay, for the AB, it will be possible to be big IA and big IB, and for the blood group A, then it will be big IA and small I. Now, so look at here. A and A over here, then it will be a homozygous. Okay, heterozygous parent can actually give birth to homozygous offspring. It is possible. Okay, so IA and IA. So the phenotype would be blood group A. Okay, and big IA and small I. Now this one is heterozygous A. Okay, and over here now A, B, and A can actually give birth back to AB. Okay, so it will be big IA and big IB for this course, then it will be AB, and finally over here it will be big IB and small I. Okay, then it will be a B. So if that's the case, then this AB parent and the heterozygous A parent, then they can give birth to 50% of chance having blood group A, 25% of chance having blood group AB, and 25% of chance having B. But it is impossible, okay, 0% of chance having O. Alright? Now you can continue work on it. Okay, just work. Okay, and you can deduce your own. Okay, tell me in the comment. Okay, if you're not sure about that. Have a very nice day.